I posted this circuit on Reddit yesterday and got quite a few comments complimenting my breadboarding skills. And this is something that I took a class back sophomore year in college that required really, really good breadboarding skills or else you'd basically drown in a pile of your own wires. I picked up a lot of tricks from my professor in that class and the other classmates, and I thought of a few of myself. And I thought that it'd be fun to compile all of them into a video for you guys to enjoy. So if your breadboards tend to look pretty messy, stay tuned. Let's start with wire strippers. That's probably the first thing you're going to need. Here are two pairs of wire strippers. They're basically the same type. They have an adjustable screw on the side, and you can kind of move that screw back and forth to dial in how thick your wire gauge is. Some of them have little, this one has gradations that says set to wire size, but there's no markings on the gradations, so you don't really, it's kind of guess. Some of them have, actual markings showing the gauges of wire you can use, or even a dial you can turn instead of a screw. You'll want to find a pair that are, really tight. This one maybe you can't quite hear it, but you can kind of hear the two blades grinding against each other as you close. That means that there's no gap between them. This pair is a little more worn out, which tends to happen where there's a gap between the two blades, so you can kind of see it there. You see my finger through that gap. When you actually go to strip the wire, a lot of times, or rather when you go to cut it, the wire will bend into that gap instead of actually getting sheared off. These actually work okay for me because I don't actually use them for cutting. I have a different tool for that, and they work fine for stripping. So if you have a crappy worn out pair, I wouldn't go shopping for a nice fancy pair because these are what I use all the time. I actually just found these when I was looking for props for this video. So those are strippers. Let's move on to cutters. I have a pretty nice pair of wire cutters. They're the angle cutters there, so I can cut things that are really close to a circuit board. That's not really necessary. It's kind of nice to have a nice neat pair with a nice sharp tip, so you can kind of get it in funny areas and cut wires. But any pair of wire cutters will do. Just make sure they do a pretty good job on solid core wire. You'll also want a pair of needleless pliers. These aren't used quite as often as you might think. There's a few cases where you need some kind of pliers because your fingers aren't quite grippy enough or sharp enough to get into some areas or pull some wires the right way. But again, there's really nothing special about them. This is a crappy pair I got out of a kit that came with like a bunch of other stuff, so it works fine for me. And this last bit is probably not quite as obvious as a small flathead screwdriver. This is a trick I picked up. I actually started by using a ballpoint pen. There's a lot of applications where you need a spudger, a really small implement you can use to pry things or whatever. So I highly recommend purchasing one of these. This also came out of the same kit with the pliers. See, they match. But small screwdriver or small pointy implement will do. Okay, so moving on to wire.
Let me show you around. That's my lab table, and this is my work stool. And over there is my intergalactic spaceship. And here's where I keep assorted lengths of wire.
The reason this video clip is so funny is because the idea of somebody having a drawer full of pre-cut wires of various lengths is ridiculous, which is why if you have one of these kits, throw it out. This is probably one of the dumbest things you can buy when it comes to breadboarding because of a number of reasons. So first of all, these wires are all different lengths, and they're all a set length that is not in any way related to the project you're working on. So it's like buying a bag of pre-cut wrapping paper. It doesn't make any sense. Also, they're all color-coded by length as if you couldn't tell how long they were just by looking at them. So you're wasting a lot of information there by doing that. If you have one of these, please just throw it out and buy this instead. By this, I mean individual spools. These are very cheap. This is 22 gauge solid core copper wire. I mean, you can buy this I got this on Amazon for like $3 a piece. Whatever you do, don't do this and buy one giant spool of all the same color. You will want to kill yourself. Instead, spread your money around, get a bunch of little ones. These will last you a long time. You won't really use, 25 feet is a lot when you consider your board is only a few inches long. So buy as many colors as you can afford. Colors you definitely want to get are red and black. Red's usually for your 5 volts, black's going to be for your ground. And there's some other signal lines. I'll show you later on how you can sort of set your own color code and what my color code is. But the more colors, the better. They come in like basically any shade you'd ever want. So lastly, of course, is the breadboard. I'm a little hesitant to pull the circuit off this breadboard for the time being, but I want to show you a few things about it. I like this one. It has a lot of space, a bunch of different rows. It has a little power grid up here, power strips. You can plug your ground, your 5 volts along here and then run it down each line. One thing to look out for with breadboards is some of them have a split power traces on the side. So right about here, there'll be a little marking, and it'll actually have a separate trace for the top and bottom halves. So if you want to use like one solid power, one solid ground line, you'll have to connect them with a little jumper. And that's one of those funny things because you don't notice it when you first start using the board because you probably have a really small circuit in one area. Then as soon as you start spreading out to the other bottom part, things stop working and you're wondering why, and it's because your breadboard doesn't work the way you think it does. So make sure you check for that when you buy a new breadboard or for the one you already have. There's really not much else to say about this. Most breadboards are the same. Don't be afraid to go out and buy another one if yours starts to suck a little bit. Sometimes if you blow up enough chips on a breadboard, the traces will fuse together. And you'll have all kinds of problems there. So you really just want to make sure to not go cheap on this because you'll totally lose your mind trying to debug some issues. This is the breadboard in this lab kit. Unfortunately, it's the only one I have lying around that doesn't currently have a circuit on it. So bear with me here, but I have enough space here to work, so we should be okay. First thing I want to talk about is chip placement and just dealing with ICs in general. You'll probably buy them in a tube such as this one, and the pins coming out of these chips are usually bent a certain way, and I'll show you what I mean when you buy them. You'll see that the pins are bent a little bit outwards. It's not entirely obvious in this video. The reason this is because a lot of times when you want to stick the chip into a circuit board, you want it to stay in so you can solder it. So they bend the pins out, so it'll kind of hold itself in, kind of like a little harpoon tip almost. So the first thing you want to do when you get a chip and you want to put it in your breadboard is to go ahead and just bend the pins back in. You can basically just put it up against any flat surface and sort of push forward until they're bent the right way. You could also, if you want, use your screwdriver and do that as well. Not quite as easy, but if you don't have a nice surface to work with, it helps. Yeah, the idea is to get them more or less at a 90 degree angle. If you don't do this, a lot of times your pins will get caught in funny ways and get bent under the chip. I once had an example where I spent probably 3 hours debugging a situation where a data line, one of my data buses had a missing pin, or I thought the pin was broken. And it took me, I actually narrowed it down to exactly which pin I knew was busted. I assumed the chip was bad, had a bad I/O. And as soon as I pulled the chip up to replace it, there it was. The pin was bent underneath it. So you can save yourself a lot of trouble by just doing this ahead of time and making sure your corners are straight. So with this, of course, you want to spread your chip across your gaps in the middle of your breadboard. It's about the only way you can put a chip in. One thing you might be very tempted to do when you have multiple chips on a breadboard is something like this. You want to save a lot of space and you want to put the chips in one right after the other. Now, I probably can't quite do it with this chip. Well, it's kind of a poor example, but some of them are sized such that you can actually do that where they butt up right against each other. I can get them pretty close like this. There's one row of gap between the pins. This is a really bad idea. The reason is because you're wasting a lot of area in between, and you want to run a lot of lines around your chips rather than over them. I'll get to that in a bit. You want to space things out a bit. If you really resort to doing this, you're going to need another breadboard. Go ahead and just buy another breadboard, get a bigger kit like this with multiple boards on it or whatever. Don't do this. Some other things you might not really think about when you're putting your chips in is try to orient them in the same way they're oriented on their datasheet. If you have a lot of data sheets next to you and you're trying to line up all the pins, it really helps you not to have to do the mental gymnastics of flipping the chip around in your brain. So you might want to go ahead and make sure they're all aligned the right way. For example, like this. And I don't know if you can see it, but they have the little nub at the top of each chip here and here. So they're facing the same direction and they're up, right side up. If you want to flip them over, that's fine. Just whatever, data sheet you're looking at, flip it over literally the page or the PDF if you can rotate the pages, because you will lose your mind trying to count pins backwards and that sort of thing. Let's say you want to run voltage lines to these chips. Now, I haven't actually looked these chips up. I don't know their pin out, but let's go ahead and just pretend that your 5-volt line is here and here, and your ground line is on the diagonal opposite end. That's pretty typical for a chip like this. Your first inclination might be to go ahead and take your wire and start stripping and cut the end off. And I'm going to tell you that's really not a very good idea. You really want to make sure your wires are exactly the length you need them. Any longer and you'll have little bends and things start popping off of the board and all kinds of mess will happen. So you want to basically custom cut the wire to the right length. Now, cutting a wire this short can be kind of difficult, so I've adapted a few tricks to doing it. So let's say your voltage line is this trace right here and ground is the other end. What I normally do is I strip one end, maybe about 1/4 inch off, and place it in, fold it over. And the idea is to basically run it through the path it would take if it was already cut. Now, this is where your handy screwdriver comes in. I only want to run this thing as short as I can, so I'm going to run it right into this hole right here so that it'll eventually get to that voltage pin. So I'm going to put a little mark on this. It might be hard to see on the video, but you could basically just put a little indentation on the wire, something small just to mark it in your eye. And then you want to pull it up. Now, a lot of times with longer traces, you want to make sure you keep all the bends you put in the wire along the way. So you don't want to yank on it because that'll ruin those bends. This is where your screwdriver comes handy. It comes in handy again. You can sort of pry it up and do that without actually ruining the shape of the wire. So before you actually cut the wire, it's since you have the big end on it, it's easier to grip. You might want to go ahead and strip that part ahead of time. So what I typically do is sort of rotate it around. A lot of times strippers have well, this pair doesn't really show it very well, but this one does. The way the angle of these things are, when you close it up, you're actually only hitting the top and bottom of the wire, not really hitting the sides. So you want to make sure you rotate the stripper around to get a nice clean cut. And then once you've done that, you can cut the end. I'm going to go ahead and cut it with these strippers, even though I usually use wire cutters for that. Cut it about the right length. And now you've got something like this. Now for a short piece of wire like this, you can try to pull the end off. You might have some difficulty with that. This wasn't that bad. If you have trouble gripping it, maybe you didn't do a very good clean on the insulation, you can grab it with your pliers like so and just yank the end off so they come in handy. So with your wire like this, you want to go ahead and bend that guy down, and now you've got a nice neat piece of wire that's just the right length, and you can stick it in your breadboard like so. And that's probably the shortest, cleanest wire you could put there. Let's see if we can do a longer one. Let's go ahead and run one of the ground lines. How about for this pin? So we want to put it on this hole right here. And we have to come from this end because this isn't a power grid. So let's go ahead and do that. I'm going to use my black wire, of course, for ground. It's kind of the universal coloring scheme for those two lines anyway. Again, strip the end. Now, one thing when you're stripping the end, which I've kind of noticed, is that a lot of times it's very hard to get the plier set so that they'll cut off all the insulation, but won't also dig into the copper itself and get caught on that. So one thing you want to do is, cut into it, rotate around, and then lift up a tiny bit before pulling off so you don't get caught on the copper there. It just saves you a headache later on when you're all, sweaty and gross and you have Cheeto fingers and whatnot. So again, we're going to bend this guy down, and we're going to place it in our breadboard and run it to our chip. Now, where to actually place this line is up to you. It probably depends on a lot of what else is going on the set, on the breadboard. Because it's going right to this corner pin, you might want to just go ahead and tuck it in here rather than running it out to the end. So let's go ahead and do that. We're going to bend it ahead of time around that chip, and we're going to mark it right where we want to cut it. So right about there. Now this wire is long enough to where you don't really have to strip it before you've cut it, so you can go ahead and cut this guy, and you've got plenty of wire to grip when you want to go ahead and strip it. So I'm going to do this. And lift up. And what I usually do is you don't want to yank on the end again because you'll ruin the little fold you made there. So you kind of pinch it, and you can kind of pry with your knuckles or with your fingertips against the wire cutters. Now, going back to my reason why I use cutters usually instead of strippers is because you can see on the end here this little barb. That's the effect of the wire getting tucked into the gap, and those on the good strippers too. So if you use a pair of cutters, you can avoid that, especially a nice pair that will just cut a nice clean edge. That barb will get caught in your breadboard all the time, and it's a pain when your wires are all like that. So with that guy cut, let's go ahead and bend our wire in a little bit. And nice and straight. And sometimes it's funny when you've made a nice, perfectly cut wire, perfectly bent wire, you forget where it came from or where it's supposed to go or the orientation. So try to keep that in the back of your head. Otherwise, you might put the wire in backwards and end up having to mess it up a little bit. And we're going to go ahead and run this guy like so. And that wasn't exactly perfect, but you get the idea. That's pretty close. So those are two very even cut wires. So let's go ahead and do something like a bus. Let's pretend that these three pins are part of a bus that connect to these three pins over here, for example. Now, buses are sort of funny. You're going to have numerous pins all going basically from the same place and to the same place, different numbers. A lot of people will tell you to use different colored wires for each line, or at least go alternate between two, like a rainbow color, that kind of thing. That way, when you get from start to finish, you can sort of catch mistakes if you put the pin in the wrong wire. I don't think it's a very good idea. I think it's a waste of colors for your wires, especially because you're putting all the pins in at the same time anyway. So if you make a mistake, it'll be really easy to debug because it'd be something you just did. It's not the kind of thing that's going to come up 10 minutes later. And in general, it's really nice to have a bus that's all the same color. That way, it just stands apart from all the rest of the wires, and individual wires that might run along that bus as well don't get caught up in the fray. So let's go ahead and do this again. I'm going to choose orange. Again, the color scheme is your own. But Orange is a pretty good color. I don't know. I think in my experience of this lab class I took, blue became my address bus wire color, and green was my data bus color, and then orange was for like other special circumstances. But whatever works for you. Just try to use as many different colors as you can, because it'll really help you out, and try to be consistent between designs. So what did I say? These three and these three. So we're just gonna pick random one, say here. And again, same sort of thing. You want to always try to bend with right angles. You don't want to have some crazy, off-angle thing. Right angles help, and I'll get to that. I'll get to why in a bit. But again, this is basically the same strategy. I'm trying to keep the wire as flat as I can to the breadboard. You don't want to start lifting up at all, because that'll cause you all kinds of problems with, it can get caught on things. And you'll see I'm going around these chips, not over them. I could do a straight shot like this. The reason you don't ever want to go over an IC is because, raise your hand if you've ever blown an IC up on a board. I know I have plenty. And you basically have to. It's kind of a rite of passage for electrical engineers. And the biggest pain in the butt is when you blow up a chip and then you have to somehow fish it out of the massive wires you have underneath it, and then, put all those wires back in and hope you didn't misplace them while you're trying to debug 6 other issues. So in general, you really want to make sure to avoid going over chips if you can at all. Remember, if you're breadboarding this anyway, it's probably all pretty low frequency stuff, so the path your wires take really doesn't matter. It might in some high frequency applications, but if you're doing RF stuff on a breadboard, you got another thing coming. So don't be afraid to go really far out of the way just to run a line if it's going to make it look neater and be easier to access later on. It'll look something like that. It's nice and neat, and it's short. Okay, so let's go ahead and do one more. I don't want to do the whole bus. It'll take forever, so I'm just going to do 2. Now, you kind of make some decisions. I might have made a poor choice here. If I'm trying to get a wire from this pin to this pin, I'm going to have to actually cross this wire, and that's might not have been the best thing. So what I should have done probably is move maybe this guy over 1. Now, I'm being lazy here because this is no longer a right angle, and that's bad, but just bear with me just to the point of demonstration. And now when you run your second one, you don't have to cross that wire at all. You can just run right next to it. It's not the end of the world if you have to, but if you can avoid it, you want to, because it's really a pain to deal with wires under wires and whatnot, if they're not very organized. They're not organized very well. All right, and now again, remember what I said about orientation. This is not the right way. You want to go this way, so it's probably pretty obvious in this example, but sometimes you can really confuse yourself with how things are supposed to be wired. And if I get this right, should go in nice and easy. There we go. Did I do that right? Let's go ahead and pretend I did. Okay, so you have your bus and it's nice and parallel and everything's great. One thing that's really cool about having everything nice and parallel is you can do some really neat tricks. For example, let's say you have like a huge bus. My data bus back on my class project was 8 pins wide, so you had a lot of, and this is going all over the board. You have a lot of problems with wires, popping up and getting caught on things. So what's nice about having them all perpendicular is you can actually assign a color of wire strictly for the purpose of holding things together. In the class I used brown. I figured that was a nice kind of dull color. I don't have any brown here, so I'll use blue instead. But what I mean by this is you can actually have a color that's designated as being a no-connect color, or just a color that connects traces to themselves, that doesn't actually do anything electrically in your circuit. It's strictly there for the purpose of helping hold things together. So for example, let's say this bus is getting kind of unruly. I can run a line from here to here. And the purpose of this line is, like I said, literally just to hold the thing down. And because you're going parallel to the traces on the breadboard itself, you actually don't affect anything electrically, assuming those pins aren't being used for anything else. So here I can put this guy right over, this. Like so. So that'll hold this 2 down. And of course, it's not at all necessary here, but with much more complicated designs, it can be. What's neat about this too is that if you make sure to make everything perpendicular, especially if you have to go from somewhere far up the board, somewhere down to the bottom, you can have your traces go out, down, and over, and that allows you to actually use this technique on the power lines themselves, on the their power traces. You can put it like this. And if you have a big bundle of wires coming off the board, they can pass under one of these, and that'll hold everything together. Just make sure you don't do one of these, because you'll blow something up. Just be kind of careful with that. So that's a neat trick, and it helps when it comes to managing a crap load of wires. One thing when you're designing is, you might be kind of afraid of passing one trace over another trace, because if you ever have to get to the previous one, the underneath one, you might have some difficulty with that. I'm here to tell you that's not really that big of a problem as long as you're careful like I am. I actually had to rewire this a number of times. When I first designed it, like I said in the article, I had actually used the wrong schematic for the display itself, so I had to redo a lot of things. So it's really not that hard, and I'll show you why. If you're really careful to preserve the angles that you've carefully spec'd out for these wires, they can be moved out of the way very easily. For example, let's say I want to get to some of these orange connections down here. Those are all kind of tucked underneath this blue. Well, first you have this yellow that's the issue, and if you're very careful with your screwdriver, you can literally pick this up, and you want to keep in mind where that was connected, but you can pick it up and just rotate it carefully out of the way. And the same goes for all these blue ones as well. You can tuck this guy up. And I actually did this while I was doing this circuit. And you can tuck all these guys out of the way, and you can access everything you need to underneath it. It's almost like lifting the hood up of your car. It's pretty neat. And actually I don't have the layout in front of me, but I can probably guess where these lines are supposed to go. I think this one goes here. As evidenced by how precise my angles are here. And everything tucks right back into where it was going. So here's another trick I learned. If you're trying to run a really short trace and you're kind of tired of having to hold on to these little tiny bits of wire, let's say your trace runs from here to here, something like 3 little pin thing. You can actually cut off a lot more insulation than you normally would, and then approximate your measurement by just laying it on top of the board like this and putting a little mark right here. Normally you would try to cut this and strip off the end from the other side, but what you can actually do here is, because you cut off so much to begin with, you can grab this little bit and actually just slide it carefully down the wire and then cut it back at the base. Now, the cool part about this is that you can cut off way more than you need to begin with and just compensate right now by choosing where to snip this guy. For example, I don't have to cut it all at the end. I can cut it right here and get just the right length. And that's a neat little trick, and it saves you a lot of effort having to deal with stripping tiny little pieces of wire. And again, you get your nice, perfect little measurements. So, that kind of thing. Neat little trick I picked up. One other thing, when you're dealing with oscilloscopes, everyone knows the trick with an oscilloscope where you can pull the head off, or the hat, or the hooker, as some people call it, because it has a little hook on the end. And you can stick the little pin, right into your breadboard somewhere to measure a trace. And this is a great idea if you really want to destroy your oscilloscope probe. I've done this a number of times, and the end just broke right off there. The pin came right out. So one trick I picked up for preventing this is to actually make yourself a little loop. And let's say, for example, you need looking at the voltage trace. That's kind of a good example. So you can actually choose the color wire that you're using for that trace anyway, for your 5-volt line. And this kind of goes along with the previous trick where you cut off, you don't really do it in the normal order, the way you cut the insulation off, where you can just cut off a crap load of insulation right to begin with. And then you can do little bits like so, carefully sliding them down. Do 2 of them this time instead of just the 1. And then cut the beginning off. When you fold this guy over, like so, and you connect it to your voltage line, let's say somewhere nice here, you now have a neat little hook onto which you can connect your hooker, like so. And this is nice because if you actually accidentally grab the probe, or you get it caught on your sleeve or whatever and you yank it off, you didn't break the probe, you just pulled the wire out of the board, and it's really not that big of a deal. And also it's nice because it automatically color codes all of your connections, so you don't have to worry about mixing those kinds of things up. These kinds of things take a lot of time. Breadboarding can take a while. You might, it is considered a quick solution, but only because it's faster than having to say, design a board and some schematic capture program, and then going to layout, and then sending it off to somewhere to get it manufactured and brought back to you, or trying to etch it yourself, which takes, almost as long once you go through the 5 times you've messed it up. It is faster than those methods, but it's still a very slow and methodical process. You just want to be careful when you're running it. You don't go too crazy and try to, get it all done really fast. I know, you're excited to get the circuit working and all that, but you'll really save yourself a lot of time and headache if you take it like this and try to spend as much time as you can just working on the board. Put on some Pink Floyd, mellow out a bit, and really spend your time on it. One other thing is worth mentioning is that basically, with the exception of the ICs and this display right here, I plan on throwing away everything on this board. All these resistors I cut just for this board. All the wires, of course, I cut just for this board. If you're really worried about reusing parts, then you should buy one of those like Radio Shack 301 kits, because when you're breadboarding, you're going to be throwing parts away. You want to make sure every part is cut just for your board. If you're trying to, if you have a drawer full of wires like Farnsworth, you're going to be wasting a lot of time and giving yourself a lot of headaches. So, buy more than you need and plan on throwing a lot of it away. That basically concludes my little tutorial. I hope you all enjoyed it, and let me know if you have any other questions or comments about my methods anywhere in the leave them in the comments. Thank you.